All right, today is more on vectors, specifically unit vectors. So from the last video, we want to find the magnitude for this vector right here. So to start off, I'm going to rewrite it as a component vector. So it would be -3, +4. And then to find the magnitude, I'm going to use the formula a squared plus b squared, and then take the square root of that. So this will give you square root of 25 or 5. So there's our magnitude. Okay, so let vector u be a unit vector in the same direction of k. So we want to figure out what vector would go the same direction, but instead of being length 5, it's going to be length 1. So how you can do this is you can take your original vector and just divide by the magnitude. That then is going to scale your vector length 5 down to a vector of length 1. So here is your note. If you have a vector AB, the unit vector, or vector with your length 1 is going to be this. So find your magnitude, divide your original vector by that magnitude. Okay, so vectors aren't always written in the component form or the like ij form. Sometimes you're given the magnitude and the direction, like it is right here. So this is telling us, if I sketch the unit circle, we're going to be at a 120-degree angle, which is somewhere over here. And the length is 50. So this would be this vector. Okay, so how do we go back to component form of this vector? I'm going to sketch it again just so you guys can see it. So you have your 120-degree angle and 50 right there. So if we sketch in your xy coordinate again, and we can sketch in x and y here, we can then find each part using like trig values. So if I want to find, let's call this A and B. If we want to find B, we know the sine of 120 is going to be the opposite over hypotenuse, or b over 50. And then you can solve this to end up getting b equals 50 sine of 120, which is then 25 root 3 if you solve it. So that would go in the y portion of our vector. And you can do the same thing for the a. You're going to end up getting that a equals 50 cosine of 120, which then is -25. So just using basic right triangle trig, you can figure out your component vector. If you don't want to think through it every single time, this is the formula. So there's your original vector. If it gives you the magnitude and direction, so it gives you this and it gives you a theta, you can find it by finding the magnitude cosine of your angle, magnitude sine of your angle, and that will give you your magnitude and direction, or your component vector. So going backwards. So here, obviously, we can find the magnitude pretty easily. So take 40 squared plus -9 squared, take the square root, and you'll get 41. Easy, got the magnitude. The direction's a little bit more complicated. So what you're going to do is you're going to pick one of these to solve. It doesn't matter which one. I usually pick cosine, but it's up to you. You can do cosine or sine. So here we know that a has to equal the magnitude and cosine of your angle. So the magnitude was 41, and we don't know what the angle is, and your a is 40. So then solve this, and you'll get 40 over 41 equals cosine of theta. Theta is cosine inverse of 40 over 41. Here, make sure you know what mode your calculator's in. If you're in radians, fine, but label it radians. If you're in degrees, make sure you label your answer degrees so you know what it is. This should give you, let me type it in quick, a decimal answer. So we want cosine inverse of 40 divided by 41. And I'm getting 12.68. One note here, make sure it's facing the right direction. So if we go back to 4.7 when we did inverse trig, cosine's only ever going to give you the top half of the unit circle. So if this angle is pointing down, it's not going to give us the right angle. So if I go up here to my original one, I'm going over 40 and down 9. So this is my vector. This angle is going up. So the way to fix that is just make it negative, which is why I like cosine, because if you get the wrong direction, you just make your angle negative. So your magnitude is 41, direction is negative 12.68. Okay, so a cannon shoots a cannonball 30-degree angle with an initial speed of 30 feet per second. So this is your magnitude. Here's your angle. To write the component form, you want 300 cosine of 30, 300 sine of 30. And then type this in. And it doesn't have to be exact, you can just use a calculator, but make sure you're in degrees because it gives you a measurement in degrees. So you'll end up getting 259.8 and 150. Okay, so what does this actually mean in real life? What this means here is this chunk, your x chunk is saying how far are you going in the horizontal direction. So like you're throwing it up, but how far is it going horizontally, or how fast is this, and then how fast is it going up or down would be your y. Okay, now it gives us the vector, and we want to go back to magnitude and direction. So initial speed, this is your magnitude. So 40 squared plus 10 squared, take the square root, and you'll get 41.23 feet per second. Okay, so how do you find the angle? I'm going to use, again, that A equals your magnitude cosine of theta. You can use sine, it doesn't really matter. So we know 40 has to equal 41.23 cosine of theta. So then theta is cosine inverse 40 over 41.23. This will give you an angle of 14.03. And the last step, always, 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 always check to make sure it makes sense. So your original vector up here went 40 in the x, 10 in the y, so you're going this direction. This angle is going this direction. Checks out, makes sense. You're going the right way. You can just leave it. And then again, go on Schoology to check the homework because it might be a little bit different.